Okay, ladies and gentlemen, before we open up our packets, we're going to take a look at a little video. There was an Honors Algebra 1 production. Today's story is about functions, metamorphosis, and introduction to functions. Remember, functions is all about input, output, domain range, x and y. So, ladies and gentlemen of Mr. Bryce's class, what was the input? If you said chickens, you're correct. And what was the output? Chicken nuggets. Okay, so we have input and we have output. Let's make sure that we understand the difference between them. So now I would like you to open up your packets to page 379. 379, that's one page beyond what we did for homework last night. If you have to hit pause, go ahead and hit pause. Okay, now on page 379 on top, we have domain and range. Now they're already in alphabetical order, which is nice. Domain just means X and range means Y. Domain means input, what you put in, and range means output, what comes out. So ultimately, all functions do is convert inputs into outputs. All they do is convert chickens into chicken nuggets. So each function has two sets associated with it. Those things that serve as inputs and those things that serve as outputs. These sets are given names. The name is the domain, that's the input, and the range, that's the output. Now, a lot of times data is given to us in many different forms. So consider this function here, y equals f of x, shown on the graph there. Evaluate each of the following. Do you notice something a little unusual about the graph? Well, we'll get to that in a few minutes. Evaluate the following. What is f of -3? What is the function value at -3? Now, I want you to pay close attention to the fact and draw that squiggly line that says f of x, and instead of writing x, we wrote -3. That means, look, where x is equal to -3. So here's where x is -3. 0, -1, -2, -3. Well, the function isn't there. Is the function down here? No. There's the function right there. What is the height? What is the y value? What is the output? X and y. Input, output. Output is the y value. X is the input, Y is the output, alphabetical value. So the Y value is just 1. Why don't you tell the person next to you what you think the function value at 1 is? I'll give you a couple seconds. Dum 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 dum. Okay, you go to 1, 0, 1, and then have to go down 1, 2, 3. So it is -3. Tell the person what the function value of 3 is next to you. 1, 2, 3. I have to go up 1, up 2, up 3, up 4, up 5. So the function value of 3 is 5. The output is 5. Can the function rule be given by the graph for a value when x is 5? Think about it. 1, 2, 3, 4, 5. Never hitting the graph. No, there can't. Because you notice there aren't arrows at the end. They stop. No, because, are they writing this down, Mrs. Robinson? The 5 is not in the domain. That's the input. It's not there. We cannot plug it in. There we go. Can't plug it in because there's nothing above or below that. Nope, can't plug it in. We can only plug in numbers from here to there. From here to there. Input and output. Is x equaling 5 in the domain of the function? I just said it. What is it? No, it's not. It's not in the domain. Give 2 other values of x. They're not in the domain. Okay, let's go around the room. Give me a number. Next person, give me a number. Keep on going right around the room. I'm just going to cheat and go 6, 7, 8, 9, 10, 11, and so on. And of course, one of you said what? 1,357,826? Okay. Circle the following y values. Oh, y values. That's the output. That's the vertical axis. That are in the range of the function. Show evidence on your graph. 0. Okay. Let me see. Do we have something that goes there? Or yep, there's part of the graph that's 0 high. So that's the output. What about 6? 1, 2, 3. You can't see that. 1, 2, 0, 1, 2, 3, 4, 5, 6. 6. Too high. Y equaling 1. Okay, there's the 1 line right there. So we have an answer there, and we have an answer there. -5. -1, -2, -3, -4, negative. How many of you are already done? Too low. +4. There's a value right there for +4. So 1 and +4 are in the output. Write down the domain and range of this function using a single inequality. Okay, this is review from week number 1, and we're already in week, what, number 28? So the domain is the x values. It goes from here to there. So -1, -2, -3, -4, -5, and +1, +2, +3. So it goes all the way from -5 to +3. What does? The x numbers. Was it a closed circle? Yes, it was. Was it a closed circle? Yes, it was. Range is the output. Goes all the way from here to there. +1, 2, 3, 4, 5. positive 5, negative 1, negative 2, negative 3, negative 4, negative 4. So it goes from negative 4 to positive 5. We always go from smallest to largest, negative 4 to positive 5. What goes? The y values. Is it a closed circle? Yes, it is. Yes, it is. Now, write the domain and range of this function using a single inequality. There it is, a single inequality. What if it's said as set builder notation? Set builder notation. Oh, yeah, we just do the squiggly, the brace. And since the letter is x that we're using there, all numbers x such that, and then we just write down the inequality. And then we close it with a brace. What if we're talking about the range? We have the y value, so we do a brace, y such that, and then we write down the inequality. There we go. Turn the page. You can see diagrams like this. Given the function f of x, the function evaluated at x equals x divided by 2 minus 3. Here's the domain. What is the range? Domain. What we plug in. F of negative 4 equals negative 4 over 2 minus 3. Where did I get that? The equation right there. I do that and I get negative 5. And that's what we do. We just draw a line segment to it, negative 5. Now if I plug in 6, f of 6 equals 6 over 2 minus 3, that's 0. And if I plug in a 10, f of 10 is 10 over 2 minus 3, which is 2. Notice that each one of these only goes to one number. Domain goes to only one range. For each input, there's only one output. That's the definition of a function. Definition of a function. For every x, there is only one y answer. What if there's two y's? Then it's not a function. You don't have to write this down, but I just wanted to show you why this is not a function. Okay, 2 goes to 1 and 2. That's why it's not a function. 3 goes to 3. That's okay. 4 goes to 2. That's okay. But because 2 goes to more than one answer, it's not a function. The range. List it in braces, negative 5, 0, and 2. Which of the following values is not in the domain of the function evaluated x, shown below? Illustrate your thinking by marking points on the graph. Okay, domain, right? It said domain, which is not in the domain. Domain is the x value. So which isn't? Negative 3, let me check. Negative 1, negative 2, negative 3. There is negative 3, so that's okay. Don't want to circle it. We might think that it's the answer. I was just highlighting it. 5. 1, 2, 3, 4, 5. There's 5. Nope, because the graph stopped there. So 5 is not. Check negative 4. Negative 1, negative 2, negative 3, negative 4. -4 is okay, and obviously 0 is okay. It said, illustrate your thinking by marking the points on the graph. So there's a point on the graph, there's the point on the graph, and there's the point on the graph. The first one was number 1, this one was number 2, and that one was number 4. Consider the piecewise linear function. What? Piecewise? Oh, that just means it changes direction. This one is a piecewise function because it doesn't just change direction, but it's made up of line segments, okay? A parabola changes direction, but it's not piecewise. Okay, that's a parabola because it's smooth. Absolute value. We'll talk about that later. Consider the piecewise linear function given by the formula. There it is. Determine the function's range. Domain range is y answers, okay? The range is the y values. Well, the easiest thing to do would be to graph it. Negative parenthesis, just do it exactly the way it looks like. Negative parenthesis x plus 2, close parenthesis, divided by, I don't care that they don't, they don't have parentheses on the bottom. I always put parentheses on the numerator and denominator. And then we're going to look at the table. It tells us to only go from -4 to +2. For that one. Okay. So if you notice, we go from -4, there's -4. The output is a 1, then -2, the output is a 0, and at 0, the output is -1, and then at 2, the output is -2. Now, this one, both of them are underlined, so we will go like that. That kind of hurts right there. If it's not on exactly the right spot, it's going to give you a wrong answer. So I typed in the equation, and I am going to go ahead and look at the table. And it says for this table, I said I'm going to look at the table. And for this table, it says go from 2 to 4. Fortunately, at 2, it still has -2. Up to 4, goes up to 6. Okay. If it didn't have the same answer here, it would not be a function because for every x, there wasn't one y. And it says determine the range. The range is the y values from -2 all the way up to 6. So you can write it from -2 to 6. That is not a point. You can write it -2 is less than or equal to y, which is less than or equal to 6, okay, because it didn't say how to write it. Or you could write for all y such that -2 is less than or equal to y, which is less than or equal to 6. Okay, now turn the page. Let's see if you can do question number 1, A, the person with the person next to you. I'm going to hit pause so you can work ahead. The next thing you're going to hear is my voice saying the answer. Okay, ladies and gentlemen, domain are the x values, range are the y values. So domain goes from here to here. So it's -1, -2, -3, -4, -5. It is less than or equal to x, which is less than or equal to, because they're filled in dots, +1, 2, 3, 4. the range. Goes from there to there. We're looking for the highest and lowest spots. -1, -2, -3, -4, -5 is less than or equal to y, which is less than or equal to +1, +2, +3, +4, +5. And that is the domain and range off of a graph. Go ahead and try B. And the answers for B, domain, G. It's right there. -4, 0, and 6. Range, right there. 12, 18, and 40. If you haven't already started working ahead, go ahead and finish this page and the next page for homework.